Hey guys, this is Mr. Win, and we're going to talk about arithmetic sequences today. Okay? Essential question: how do I determine arithmetic sequences? That's one of the words we're looking at, using the explicit rule and recursive rule. More importantly, the explicit rule and how we can write those explicit rules. All right. So first off, arithmetic sequence. If I break that down, arithmetic usually just deals with math, adding, subtracting. Sequence is it's just a list. Okay, it's a list of numbers in a specific order. All right, and each of those numbers, each of those numbers in that order is called a term. So each element in a sequence is called a term. For an example, if I look at a table, and let's say the x values, so here's your x, here's your y, is just your position number, the position in that pattern. So position 1, 2, 3, 4, 5, 6. So if I say the first term, you're looking at the first number, right? If I say the second term, you're looking at the second number. Third term, so on. Excuse me. Okay? So let's figure out the pattern here. If I have enough information here, I noticed that to go from 3 to 7, I have to add 4. From 15 to 9, I have to add 4. So it looks like I'm going up by 4 each time, right? So let's go up by 4. So 7 plus 4 would be 11. 19 plus 4, 23. So I fill out the rest of the table. It's a pattern, okay? So I'm going up by 4 each time. That's my pattern. And if you notice, this is function notation. F of 1, okay? All that means is the function of 1. The 1 inside that parentheses tells you which term number. Because if you notice, you see an f of n here. Don't you see n here? And as an n inside the parentheses. So what number is inside this parentheses? Go to that n, which is right here. Okay, so n of 1, the value would be 3. So our answer would be 3. Basically, that's saying, what's your first number? What's the first term? And then for f of 3, what's the third number? What's the third term? Which would be 11. F of 5, and I'm just looking at the tables over here. F of 5, what is the fifth number in that pattern? 19. F of 7, what's the seventh number? Well, it's not on the table, but I can figure that out. If I just continue this and add 4, which would be 27. Okay? And domain and range. Remember, domain is all possible x values. Okay, if you don't remember. All possible, x's. And then range is all possible, y's. So that means, and this is a table, right? Our patterns are going up. The x values are the position number, first term, second term, third term, fourth term. So I'm just going to list them all. 1, 2, 3, third term, right? Fourth term, fifth term, sixth term, seventh term. And the pattern does continue, so let's just draw that it continues. And then the range, do the same, but list the y values, the term number, of that sequence. So f of n, so 3. I'm just looking at the table, listing the y values. 7, 11, 15, 19, 23, 27, and so on. Okay? So we do list them. Again, these are just discrete values. We're not talking about a continuous graph. Patterns go by first term, second term, third term. You don't have half a term. So you do list them when it's discrete. Okay? All right, let's talk about the two types of sequences, or the rules around these sequences. There's an explicit rule, and there's a recursive rule. One way I like to remember explicit rule is where you can find the nth term without using any previous numbers. So whatever number you want to find, if you wanted to find out the 500th term for some reason, you can find out as long as you have the explicit rule. You find out any number. The recursive rule, you need to know the previous term to find the 500th term. So if you want to find the 500th term, you need to know the 499th. You can only go step by step. 1, 2, 3, 4. You're adding 4 each time. That's the recursive rule. Explicit rule, it tells you what to do with that number for any term. Okay? One way I like to remember, recursive kind of looks like repeat. So to get the recursive form, you got to repeat the previous term. Okay? So let's look at explicit rule first. This is the rule. Usually your rule comes in function notation. It says f of n and then equals, and then a rule. The rule here is that n has to be squared right here. N has to be squared, and then you add 3. So if I get f of 1, right, notice how 1 is inside the parentheses, right? and 1 is also where the n is. So 1 squared plus 3, which would be 4. If I want to know the second term, f of 2, you got to square the 2, add 3 again. So 2 squared is 4, 4 plus 3, 7. If you want to know the third number, the third term, square the 3, add 3. So 3 squared is 9, plus 3, 12. F of 4, I want to know the fourth number in the pattern. You have to square the 4, add 3. So 4 squared is 16, plus 3, excuse me, 19. Okay? So notice there's a rule. Like if you want to find the fourth number, square the 4, add 3. There could be a rule where you multiply the 4, whatever, you do something to the 4, and then you get your answer, okay? You can find any number. So if I ask you to find the 100th number of this pattern, it's possible because all you got to do, okay, let's replace the 100 with the 100 squared plus 3. 100 squared is 10,000. 10,000 plus 3, it's just 10,003. Okay? Now let's find the recursive rule. Recursive rule, there's always two things. You're given your first term. So do you notice how it says given? The first number is always given. F of 1 is always called, it's your first term. First number in the pattern. And then the rule generally looks like this. F of n equals f of n minus 1 plus 3. What this part says, the f of n minus 1, all that means is f of n is the term number you're looking for, and minus 1 would be 1 before that previous term. Remember when I talked about repeating numbers? Right? Repeating the term, so you're getting the previous term. So go back 1 and then add 3. That's all that rule is saying. So really the important parts here are what your first term is, 5, and what it's changing by, plus 3. So we know 5 plus 3, notice it gives me 8 for the second term. So if you want to find the third term, you would take the second term, which was 8, add 3 to that, gives you 11. And if you want to find the fourth term, so all you're really doing is you're looking back at these numbers over here, and then you're adding 3. So 11 plus 3, 14. So you notice how we're just going step by step on our pattern. This is probably what you're already doing in your head. So naturally you would do this, go pattern step by step, okay? This is what recursive rule does. You're repeating the previous term. So 14 plus 3, 17. And really all you can get is the next term. So if I want to find the sixth term, you do 17 plus 3, 20, and so on, okay? You can't find out a number like say the 100th term like we did with the explicit. You'd have to go all the way to the 99th term and then you'd be able to find out. Okay? Alright. Let's talk about a situation here. Domino's is having a special. If you order a large pizza for the regular price of $12, you can order any number of additional large pizzas for $5. Now that's a little incorrect, okay? Domino's, they kind of change it. $5 a piece is a little too cheap, so let's do $8.50. Okay, use the recursive rule. F of 1 equals 12. Okay, again, this is a recursive. And f of n equals plus 850. So again, if you notice, I'm going to highlight those again. What you need to know in a recursive rule, where you start is 12, and what is changing by. So add 850 each time. Okay, let's look at that. F of n1. So first function, f of 1, is always given, which you start with is $12. F of 2, if you buy 2 pizzas, you still have to pay the $12, so your first price, plus $8.50, which would give me $20.50. If you want to buy another pizza, a third pizza, so look back, how much did it cost for 2 pizzas? Well, that was $20.50, and then add on $8.50, which would give you $29.50. And again, if you want to buy 4 pizzas, well, how much did it cost for 3? $29.50, and then add on $8.50. Gives you $37.50, and so on. Okay, well, let's graph that. F of 1 is 12, f of 2 is $20.50, f of 3 $29.50, and then $37.50 for 4 pizzas. And now you do count pizzas, so do not draw a line. It is discrete, and if it's discrete, list your x values. X is here, y is here, so 1, 4, so on, and the y values, all possible y values. All right, that's the first part of arithmetic sequences. Thank you.